So the top two boxes in the first row are unchecked. The second row, both boxes are checked. So now we're going to drag an atom from one of the boxes below. I'm going to make sure I choose atoms that are not in your activity so that I don't ruin all your fun. So we're going to do K, and then we're going to do O. So in your activity, it tells you to first draw the Lewis structure of the compound. Notice only the Bohr models are drawn here. Please remember on the Lewis structure of the compound, if it's ionic, you're going to draw ions. Okay, the Lewis symbol of the ions. Notice you can't see the whole compound, so you're able to zoom out here, and we can see the Bohr models for K and for O. And there's two Ks. And now I'm going to hit play. And now we noticed a couple of things. We have charged ions formed, K 1 plus for the Ks and 2 minus for the O. We also noticed the coloring. So the blue means there's a charge of plus, and the red means there's a charge of negative. And so in your packet, it tells you to subtract the electronegativities. And once you get the value, you compare it to the values that appear here for the different types of bonds, which also should be in your packets or your notes. And so when you determine the type of bond, you're going to drag it over here, and you're going to check down to the left of the clear button to make sure you are correct. Let's just do one more, and I'm going to choose chlorine and by the way, it says to clear on your activity. It says to clear this, but just leave all your compounds that you build there. So I'm going to try a compound between chlorine and oxygen, and I'm going to draw the Lewis structure, add my notes, because what is shown on the simulation is only the Bohr models. You'll be drawing the Lewis symbols and Lewis structure. So notice all the atoms, chlorine and oxygen, are purple, but when I hit play, they change colors. We notice a couple things here. It is more red around oxygen, and it is more blue around chlorine. Now, notice these are both nonmetals, so they don't form ions. However, most of the electrons are around oxygen, as indicated by the red color, and this partial negative sign that you heard about in the video. This is a lowercase Greek delta sign. It kind of looks like an S with the bottom closed, and it's partially negative. Why is it partially negative? Because most of the electrons are around oxygen versus chlorine, which is labeled partially positive. Now, how do we know that one is more electronegative than the other? If we look at the tables, at the table in our back of our packet or the bottom right corner of our yellow periodic table, we can see that chlorine is more electronegative than oxygen. Oh, actually, it's the other way around. Sorry, oxygen is more electronegative than chlorine. I'm reading my table now. Oxygen has a value of 3.5 and chlorine has a value of 3.0. So we would indicate the partial negative, not a true negative, because these are not ions, with a partial negative sign. And because I calculated the difference between the pulling on the electrons between Cl and O, I can see this is a polar covalent bond. So I drag the molecule here and check that I'm correct. So please let me know if you have any questions, and thank you for watching.